Hello and welcome. In this unit, this lesson, we'll be talking about greatest common factor, also known as GCF. We're going to go over a few things that you should know already. Recall that 2 and 3 are said to be factors of 6 because the product of 2 and 3 is 6. Recall that product in math means not anything that's produced, but what is produced as a result of a multiplication. So likewise, the product 7AB, the 7, the A, and the B are called factors of the product. If a positive integer greater than 1 has no positive factors other than 1 in itself, then it is called a prime number. The prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17, and 19. A positive integer greater than 1 that is not prime is called a composite number. To factor 90 means to write it as a product of 2 or more numbers. To factor it completely means to write it as a product of primes. So, for example, 90 equals 1, that should say 9. 9 times 10 is a factorization. 90 equals 2 times 3 times 3 times 5, or 2 times 3 squared times 5 is the prime factorization of 90. Similarly, to factor a polynomial is to write it as a product of simpler polynomials. To factor a polynomial completely is to write it as a product of polynomials that cannot be factored further. As an example, x cubed minus 9x is equal to x times the quantity x squared minus 9 is factored. But x cubed minus 9x is equal to x times x plus 3 times the quantity x minus 3 is factored completely. The greatest common factor or GCF of 2 or more integers is the greatest integer that is a factor of all the integers. An example, find the GCF or the greatest common factor of 24 and 60. Now I'm going to show you another way of doing factoring. You may be familiar with finding the factor trees, so like take 24 is 6 times 4, and 6 is 2 times 3, and 4 is 2 times 2, and that's fine, it works, but here's another way to look at it that takes up less space. 24, so since the smallest prime number is 2, I want to ask, can I divide it by 2? And since 24 is even, it is divisible by 2. It goes in 12 times. And then I just ask myself that again, is 12 divisible by 2? It is, and it goes in 6 times. 6 divisible by 2? It is, and it goes in 3 times. Now 2 does not go into 3, but 3 will, and 3 is prime, so I put 3 here, and 3 goes into 3 1 time. And when you get to 1, you're done. the prime factorization of 24 is 2 times 2 times 2 times 3. So the numbers here on the right. So we can do that again with 60. The prime factorization of 60 would be 2 times 30, and 2 goes into 30, 15. And 2 won't go into 15, but 3 will, and it goes in 5 times. And while 3 won't go into 5, 5 will, and it goes in once. And so these are the prime factors of 60. 2 times 2 times 3 times 5. So then the greatest common factor, we can just circle the ones that they have in common. And they have in common 2 2s and 1 3. And then we just multiply those together. So 2 times 2 is 4, and 4 times 3 is 12. And so the greatest common factor of 24 and 60 is 12. The greatest common factor of 2 or more monomials is the product of the greatest common factor of the coefficients, which is the numbers before the variables, and the common variable factors. As an example, find the greatest common factor of 6x cubed times y and 8x squared y squared. So 6x cubed y is 2 times 3, the prime factorization, times x times x times x 3 times, and times y. And then the prime factorization of 8 would be 2 times 2 times 2. And then there's 2 x's, so times x, and y squared, which is by times y. And then we circle the ones they have in common. They have 2 in common, and they have 2 x's in common, and they have 1 y in common. And so 2 x times x is x squared and y. So 2x squared y would be the greatest common factor of 6x cubed y and 8x squared y squared. Notice that the exponent of each variable in the greatest common factor is the smallest exponent of that variable in either of the monomials. All right, thank you. Let's go practice.